Think your IKEA furniture is hard to assemble? Vikings built entire warships in just 10 hours without a single Allen wrench or YouTube tutorial. These weren't just any boats, they were engineering marvels that could outrun, outmaneuver, and outlast anything else on the water. While modern shipbuilders need massive industrial facilities, computer designs, and millions of dollars, Viking shipwrights needed only an axe, a few simple tools, and knowledge passed down through generations. What they created changed the course of history. Today, we're stripping away the Hollywood myths to reveal exactly how these master craftsmen built vessels so advanced that modern naval architects still study them. And trust me, what these bearded boat builders accomplished with nothing but hand tools will make your power drill look like a child's toy. The Viking ship advantage. Before we dive into how Vikings built their ships, let's understand what made these vessels so special in the first place. Viking longships weren't just transportation. They were weapons of war, trading vessels, and exploration vehicles, all rolled into one wooden package. Think of them as the F-150 trucks of the medieval world. Versatile, reliable, and able to handle whatever you threw at them. These ships could cruise at 12 knots with just a handful of rowers. For comparison, that's about 14 miles per hour, faster than most modern sailboats and comparable to what you'd get from a small outboard motor today, except they didn't burn a drop of gas. But speed was just the beginning. These ships had a draft of less than 3 feet, meaning they could navigate shallow rivers and beaches where other ships would run aground. Imagine taking your ocean-going vessel and suddenly pulling up directly onto a beach. No dock, no harbor, just straight from sea to land. That's like driving your car straight from the highway into a shopping mall. The longship's flexibility was its true superpower. The oak and pine construction created a hull that actually flexed with the waves instead of fighting against them. Modern boats are rigid by design. Vikings understood that working with nature beat working against it every single time. And perhaps most impressive of all, these ships could be carried over land when necessary. Try doing that with your 25-foot bayliner, the material selection process. So how did Vikings create these maritime marvels? It started long before the first piece of wood was cut. Viking shipbuilders weren't just grabbing whatever trees were convenient. They were essentially nature's talent scouts, searching the forest for trees with very specific qualities. This wasn't about finding the biggest or straightest trees. It was about finding the right natural curves. Oak was the primary material for the keel and structural components. It's dense, water-resistant, and tough as nails, literally, since the Vikings used oak's natural strength instead of metal fasteners in many places. If you've ever tried to drive a nail into oak with a hammer, you know exactly how strong this wood is. Pine, meanwhile, was used for planking. It's lighter, more flexible, and easier to shape than oak. This combination of woods created the perfect balance of strength and flexibility. But here's where Viking shipbuilders showed their true genius. They used what modern shipwrights call grown timber. Instead of forcing straight boards to bend into curved shapes, they found trees that naturally grew in the curves they needed. Think about that for a second. These guys would walk through forests looking for trees with specific bends and curves, mentally cataloging each one as a potential ship part. That Y-shaped oak, perfect for a stem post. That curved pine, ideal for a rib section. This wasn't just clever recycling, it was engineering brilliance. A naturally curved piece of wood is significantly stronger than a straight piece that's been forced to bend. The wood grain follows the curve, creating structural integrity that can't be matched by manufactured methods. Modern boat builders have actually rediscovered this technique, with some high-end wooden boats now using grown knees for critical structural joints. What's old is new again, except Vikings were doing this 1,000 years ago without the benefit of forestry management or timber farms. The Vikings' material selection process was so sophisticated that they could identify the perfect trees just by looking at them. They understood wood grain, strength, and flexibility in ways that would impress modern materials engineers. They weren't just woodcutters, they were wood whisperers, the Viking Toolkit. Now, let's talk tools. If you're picturing some primitive stone axes and crude implements, think again. Viking shipbuilding tools were simple but incredibly effective. Specialized instruments, refined over centuries. The axe was the Swiss Army knife of Viking shipbuilding. But these weren't just any axes. Viking shipwrights used specialized broad-headed axes that could fell trees, rough-cut logs, and even perform fine shaping work. The versatility of these tools would make your all-in-one power tool jealous. Think about your garage workshop for a second. You probably have different tools for cutting, shaping, drilling, and smoothing. Vikings did all of that with just a handful of specialized hand tools. The adze was essentially a horizontal axe used for hollowing out beams and smoothing surfaces. Imagine trying to create a perfectly smooth curve on a piece of oak using what looks like a hoe. That's craftsmanship. The draw knife, a blade with handles on both ends, was pulled toward the body to shave and shape wood with remarkable precision. This simple tool could create smoother surfaces than most power sanders, all while giving the shipwright perfect tactile feedback through the handles. For drilling holes, Vikings used a simple hand-powered auger. No batteries, no electricity, just muscle power and skill. Yet the holes they drilled were precise enough to create watertight seals. When wooden pegs or iron rivets were driven through them, perhaps most surprising was their measuring system, or lack thereof. While they did use simple measuring sticks for basic proportions, much of the work was done by eye or using body parts as measuring tools. A hand's width, a forearm's length, a thumb's width. These were the units that built ships capable of crossing oceans. For marking cutting lines, they used charcoal dust, or soot-covered cords that could snap a straight line onto wood, a technique still used by carpenters today, though now with chalk instead of soot. What's remarkable isn't just that Vikings built ships with these simple tools, it's that they built them so quickly and with such precision. A skilled team could assemble an entire longship in about 10 hours once the wood was prepared. Try building anything seaworthy in that time frame today, even with a fully stocked workshop and power tools. The Viking Toolkit reminds us that technology isn't always about complexity. Sometimes it's about perfecting the simple things. These craftsmen could do more with 5 hand tools than many modern builders can do with an entire workshop of power equipment. If you are enjoying Raiding the Past with us, then pillage the like button and subscribe for more content on Midgard living. The keel, the backbone of Viking engineering. Every great project needs a solid foundation, and for Viking ships, that foundation was the keel, the literal backbone of the vessel. The keel of a Viking ship wasn't just a straight piece of wood, it was carefully selected and shaped from a single oak log, carved and planed by hand until it held just the right shape. This wasn't just any shape either. It had what shipbuilders call shear, a slight upward curve toward both ends. This curve wasn't decorative, it was functional engineering at its finest. The shear helped the ship ride waves instead of slamming into them, similar to how modern boat hulls are designed. It's like the difference between driving over speed bumps, with good suspension versus bad suspension. The Vikings understood this principle 1,000 years before automotive engineers. Once shaped, the keel was laid on a level base, usually supported by logs or stones. Everything else would be built up from this foundation. If the keel wasn't perfectly positioned, the entire ship would be compromised, like building a house on a crooked foundation. Next came the stem and stern posts, the rising pieces at each end of the ship. These weren't just straight posts jammed onto the ends of the keel. They were carefully selected curved pieces, often from naturally bent trees, that created the ship's distinctive sweeping profile. These curved end pieces weren't just for looks, they were critical to the ship's performance. The upward sweep reduced drag and helped the ship slice through waves rather than plow into them. It's the same principle used in modern ship design, except Vikings figured it out through trial and error, rather than computer modeling. With the keel and end posts in place, the shipwrights began adding the ribs, the curved frames that would give the hull its shape. Each rib was carefully carved to precise angles, all done by eye, without the benefit of blueprints or CAD software. These ribs weren't placed at random intervals. They were positioned with mathematical precision to distribute the stresses of the sea evenly throughout the hull. The spacing between ribs was critical. Too far apart, and the hull would flex too much. Too close together, and the ship would be unnecessarily heavy. The ribs were attached to the keel using wooden dowels or iron rivets, creating a flexible but incredibly strong framework. This skeleton would determine the final shape of the ship. Not flat and boxy like a modern pontoon boat, but curved and flowing like a fish. By the end of this stage, the ship looked like exactly what it was, a skeleton pulled from the sea. But this skeleton contained all the engineering brilliance that would make Viking ships the most advanced vessels of their age. Modern shipbuilders still use many of these same principles, though now with the aid of computers and power tools. The Vikings did it all with hand tools and intuition, creating designs so effective that they remained largely unchanged for centuries. Clinker planking, the secret to Viking speed. With the skeleton in place, it was time for the Viking shipwrights to add the skin. the planking that would transform the frame into a seaworthy vessel. And here's where Viking shipbuilding truly separated itself from everything else on the water. Vikings used a technique called clinker planking, also known as lapstrake. Instead of placing planks edge to edge like modern boats, they overlapped each plank like fish scales or wooden shingles on a roof. Each plank slightly overlapped the one below it, creating a distinctive ridged appearance. This wasn't just an aesthetic choice, it was engineering genius. The overlapping planks created a hull that was both lightweight and incredibly strong. When waves hit the ship, the clinker-built hull could flex and absorb the impact, instead of fighting against it. Think of it like modern shock absorbers on your truck. They don't resist the bumps in the road. They absorb and dissipate the energy. Viking ships did the same thing with ocean waves, making them faster and more seaworthy than the rigid hulls used by other cultures. Each plank had to be hand-shaped to fit perfectly against the curve of the ship. This wasn't like slapping together flat boards. Each plank was a unique piece of the puzzle, carved to follow the exact contours of the frame and the planks around it. The planks were fastened with iron rivets, hammered through pre-drilled holes and clenched tight, with metal washers on the inside. These rivets weren't just hammered in randomly, they were placed in a precise pattern that distributed stress evenly across the hull. What's truly remarkable is how thin these hulls were, sometimes just an inch thick. Modern boats rely on much thicker hulls for strength. But the Vikings understood that the clinker design created strength through its structure rather than through brute material thickness. The result was a hull that was incredibly light for its size. This lightness translated directly into speed and maneuverability. A Viking longship could outrun almost anything else on the water, not because it had more power, but because it had less resistance. It's like the difference between trying to push a shopping cart and a wheelbarrow loaded with the same weight. The wheelbarrow, with its better design, moves more efficiently despite having identical contents. Viking ships simply moved through water more efficiently than anything else afloat. As the planking rose up from the keel, the ship took on its final shape, wide in the middle, narrow at the ends, designed to slice through waves like a knife. The overlapping planks created a naturally water-resistant hull, as water had to fight against gravity to work its way up between the overlaps. Modern fiberglass boats achieve water tightness through chemical bonds and sealants. Vikings achieved it through clever design and precise craftsmanship. No caulking, no sealants, just wood fitted so perfectly that water couldn't find its way in. The dragon head. Form meets function. The final piece of a Viking longship wasn't structural. It was symbolic. The dragon head mounted at the prow was the finishing touch that transformed a wooden vessel into a creature of legend. Carved from a single block of wood, these dragon heads weren't just decorative afterthoughts. They were carefully designed pieces that served multiple purposes: practical, psychological, and spiritual. From a practical standpoint, the dragon head extended the waterline of the ship, improving its hydrodynamics and helping it cut through waves more efficiently. It's similar to how modern performance boats have pointed bows that slice through water. But the real power of the dragon head was psychological. Imagine you're a peaceful coastal villager, waking up at dawn to see a fleet of ships approaching, each one adorned with a snarling beast. The intimidation factor alone was worth the effort of carving these elaborate figureheads. Viking sagas tell us that these dragon heads also served a spiritual purpose. They were believed to protect the ship and crew from sea monsters and evil spirits. When approaching friendly territory, the heads would be removed as a sign of peaceful intentions, the medieval equivalent of lowering your weapons. No two dragon heads were exactly alike. Some were fierce with snarling teeth and flared nostrils. Others were more abstract, twisting serpents, stylized beasts, even mythical birds. Each ship had its own identity, its own guardian spirit embodied in the carved head. Fitting the head to the prow was a precision job. It had to align perfectly with the keel and stem post, off by an inch, and it would look crooked from every angle. Carving and placing it was like threading a needle with a battle axe, requiring both brute force and delicate precision. Once mounted, the dragon head transformed the ship from a mere vessel into something alive, a creature with a spine, ribs, and a face, ready to cross oceans or conquer them. It was the final touch that made Viking ships not just transportation, but symbols of power and identity. Modern boats have largely abandoned figureheads in favor of clean, utilitarian designs. But there's something lost in that transition: the connection between vessel and crew, the sense that a ship has its own spirit and personality. Vikings understood this connection on a deep level, creating ships that were extensions of themselves and their culture. The speed secret: why Viking ships outpaced modern designs. With the dragon head in place, the ship was complete, ready to take to the water and demonstrate why Viking vessels could outpace modern boats, despite having no engine, no metal hull, and no advanced materials. The secret to Viking ship speed wasn't just one thing. It was the perfect combination of multiple factors working together, like a well-tuned V8 engine, where every component contributes to the whole. Viking ships achieved their legendary performance through holistic design. First, there was the weight-to-strength ratio. By using naturally curved wood and the clinker planking technique, Vikings created hulls that were incredibly strong while remaining lightweight. Modern boats often sacrifice speed for durability by using heavier materials. Vikings found a way to have both. Second, there was the hull shape. The long, narrow design with a shallow draft created minimal resistance in the water. It's like the difference between pushing your hand through water with your palm flat versus with your hand in a knife-edge position. The Viking hull was essentially a wooden knife, cutting through the sea. Third, there was the flexibility of the hull. Unlike rigid modern boats that fight against waves, Viking ships worked with the water, flexing and adapting to conditions. This flexibility converted wave energy into forward motion rather than wasting it on up and down movement. Fourth, there was the sail design. Viking square sails were surprisingly efficient, especially when running before the wind. They could be adjusted quickly to changing conditions, allowing the ship to maintain optimal speed regardless of weather. Finally, there was the human element. Viking crews were highly trained, working in perfect coordination to maximize their vessel's performance. When the wind failed, they could switch seamlessly to oars, maintaining speed when other ships would be dead in the water. The combination of these factors created vessels that could sustain speeds of 10 to 12 knots under good conditions, comparable to modern sailboats, despite being built 1,000 years earlier with nothing but hand tools. Modern replicas of Viking ships have consistently surprised naval architects with their performance. The Viking Ship Museum in Roskilde, Denmark, has built several authentic reproductions using traditional methods. These ships have not only proven seaworthy, but have actually crossed the Atlantic Ocean, retracing the roots of their ancestors. One such replica, the Sea Stallion, sailed from Denmark to Dublin in 2007. Despite facing rough North Sea conditions, the ship averaged speeds that would make modern sailors envious. The crew reported that the ship handled waves in ways that felt completely different from modern vessels, more like riding a living creature than controlling a machine. This performance isn't just impressive, it's humbling. With all our modern technology, computer-aided design, and advanced materials, we haven't fundamentally improved on what Viking shipwrights created with axes and adzes over 1,000 years ago. Think about that for a second. We've gone from horse-drawn carriages to supersonic jets, from smoke signals to smartphones. But the basic principles of efficient ship design were already mastered by men working with hand tools in the early medieval period. It's like discovering that ancient Romans had developed a working pickup truck, but the knowledge somehow got lost. The Viking longship wasn't just good for its time, it represented a peak of efficiency that would take centuries to fully understand and appreciate. The Viking shipbuilding legacy. So what happened to these incredible shipbuilding techniques? Why aren't we all sailing around in updated versions of Viking longships? The answer lies partly in changing needs. As trade routes expanded and cargo volumes increased, ships needed to carry more goods and fewer warriors. The sleek, fast longship gave way to broader, deeper vessels designed for capacity rather than speed. The introduction of cannons in naval warfare also changed ship design dramatically. The flexible, lightweight hull of a Viking ship couldn't support heavy artillery. Naval architects began building rigid, heavily framed vessels that could carry dozens of cannons, sacrificing speed and maneuverability for firepower. By the time of the Industrial Revolution, wooden ships were being replaced by iron and steel vessels powered by steam rather than wind and muscle. The age of the Viking shipwright had passed. But not everything was lost. Many of the principles developed by Viking shipbuilders live on in modern wooden boat construction. The concept of grown timber has been rediscovered by high-end wooden boat builders. The clinker planking technique is still used for certain types of small craft, where lightweight strength is crucial. Even more surprisingly, some ultra-modern racing sailboats have returned to the Viking principle of flexible hulls that work with the water rather than against it. Carbon fiber has replaced oak, computer models have replaced the shipwright's eye, but the fundamental insight remains the same. A boat that can flex and adapt moves more efficiently through water. Naval architects studying Viking shipbuilding techniques have been consistently amazed by how these ancient craftsmen solved complex hydrodynamic problems through intuition and experience. Without any formal understanding of physics or fluid dynamics, Vikings created vessels that embodied principles we now teach in engineering schools. It's a powerful reminder that technology isn't always about complexity. Sometimes the most elegant solutions come from deep understanding, rather than advanced materials or complex designs. The Vikings didn't have power tools or computer simulations, but they had generations of accumulated knowledge and the wisdom to work with nature rather than against it. The 10-hour miracle, how they built so quickly. Perhaps the most astounding aspect of Viking shipbuilding wasn't the design itself, but the speed at which these vessels could be constructed. Historical records suggest that a skilled team of Viking shipwrights could assemble an entire longship in as little as 10 hours once the materials were prepared. Let that sink in for a moment. 10 hours. That's less time than it takes most of us to assemble a piece of IKEA furniture, let alone a seaworthy vessel capable of crossing oceans. How was this possible? The answer lies in preparation, teamwork, and a modular approach to construction that would make modern manufacturing engineers proud. First, there was the preparation. Long before the actual assembly began, Viking shipwrights would have all their materials ready. The keel shaped, the planks cut, the ribs carved, the rivets forged. This wasn't included in the 10-hour assembly time, but it was a crucial part of the process. Think of it like those cooking shows where all the ingredients are pre-measured and chopped. The actual cooking goes quickly because all the prep work is done in advance. Viking shipbuilding worked the same way. When assembly day came, everything was ready to go. Second, there was the teamwork. Viking shipbuilding wasn't a one-man job. It was a community effort involving specialized roles. Some men would hold planks in place, others would drill holes, still others would hammer in rivets. Women often participated too, especially in creating the woolen sails and the ropes needed to control them. This division of labor created efficiency that would impress any modern production manager. Each person knew their role and performed it with practiced precision, creating a workflow that minimized downtime and maximized productivity. Third, there was the modular approach. Viking ships were essentially kit-built, with standardized components that could be quickly assembled. The ribs, for example, would be pre-carved to the correct shapes before assembly day. The planks would be rough cut, needing only final shaping to fit perfectly against the ribs. This standardization meant that shipwrights didn't need to stop and figure things out during assembly. They already knew exactly how each piece would fit together. It's the same principle used in modern manufacturing, just without the factory floor and conveyor belts. The speed of Viking shipbuilding had practical advantages beyond mere efficiency. It meant that a Viking community could replace lost ships quickly, maintaining their naval power even after defeats. It meant that they could expand their fleet rapidly when opportunities for raiding or trading arose. Most importantly, it meant that shipbuilding knowledge was widely shared within the community. Unlike later periods, where shipbuilding became the domain of specialized guilds with closely guarded secrets, Viking shipbuilding was a community skill. Many hands made light work, but they also ensured that the knowledge was preserved across generations. Modern boat building, with all its advanced tools and materials, typically takes months or even years to complete a vessel of similar size. We've gained precision and durability, but we've lost the speed and community involvement that characterized Viking shipbuilding. The Viking longship wasn't just a boat, it was a masterpiece of engineering created with nothing but hand tools and generational knowledge. These vessels could cruise at 12 knots, land on any beach, survive the open ocean, and be carried over land when necessary. They were the perfect tool for a people who lived between sea and land, who saw water not as a barrier, but as a highway. What makes Viking shipbuilding truly remarkable isn't just what they built, but how they built it, using naturally curved wood, simple tools, and techniques refined over centuries. They created vessels that embodied principles naval architects would only formally understand hundreds of years later. The speed of their construction process, assembling an entire ship in just 10 hours, would impress even modern manufacturing engineers. The community involvement in shipbuilding ensured that knowledge was preserved and shared across generations. Today, as we rely increasingly on computer designs, power tools, and synthetic materials, there's something profoundly humbling about what these medieval craftsmen accomplished with axes and adzes. They remind us that technology isn't always about complexity. Sometimes it's about deeply understanding materials and working with nature rather than against it. The next time you see a sleek, modern yacht or a powerful speedboat, remember the Viking longships that preceded them by a millennium. Remember the shipwrights who could look at a curved tree and see a ship's rib, who could build ocean-crossing vessels without a single blueprint or power tool. They weren't just building boats, they were creating the vessels that would carry their culture across oceans, changing the course of history and leaving a legacy of craftsmanship that still inspires awe 1,000 years later. If you enjoyed this deep dive into Viking shipbuilding, pillage that like button and subscribe for more content on Midgard living.